Hey guys, welcome to lesson 5. Today we're going to be talking about something called a board account. So this is going to be a new voting technique that we are going to learn about today that's a little bit different than the voting techniques that we learned about last week. All right, so this is another one that we're going to add to our tool belt, analyze, see what kind of problems there are with it, see the advantages of it. But today what we're going to focus on is just the mechanics. How does the Borda count work? All right, so just a little bit of history. Borda count was named for a guy named Jean Charles de Borda. He developed the system in 1770, and its main purpose was to essentially ensure that if you had a really objectionable choice, like a situation where you had a group of people that really liked one candidate but no one else liked him, like everybody else voted against them, made him their last choice. That situation is what we call an objectionable candidate. And the board account is kind of a way of making sure that the most objectionable person doesn't end up winning the vote. All right, so that's one of its main advantages. And we're going to see that in our first example here. All right, so let's take a look at that example. We have a group of mathematicians that are getting together for a conference. They're trying to decide where to have the conference, and so they're coming from 4 different cities here. We've got Seattle, Tacoma, Puyallup, I think that's how that's pronounced, and Olympia. And the locations of where those cities are located are over here on the map. All right. So they all took a vote to decide which of those 4 cities to hold their conference in, and we have their preference schedule right here. All right. In that situation that I was telling you about, where you have your group of people that really like Seattle, right? If I were looking at this for a plurality vote, it looks like Seattle would win the plurality because it has the most first place votes. But when you look at the other schedules here, you'll notice that Seattle is at the bottom. Like, no one else but these 51 people really want to go to Seattle. So if we did a plurality vote, these 51 people would be very happy, but the rest of the people in this vote would be very unhappy, right? So that's why Seattle's very objectionable. In contrast, you might look at Tacoma. Like, if we were doing a plurality vote, Tacoma has the second most first place votes. And if you look at where Tacoma is placed in the other preference schedules here, it's pretty high up. It's second. It's the second choice for everybody else in this vote. So Tacoma would be what we would call the least objectionable choice in this particular vote. All right. So let's see how board account plays out in this situation. All right. So the way that board account works is we assign points. So this is a way of actually getting some value. Like, if you do get a second place finish in a schedule somewhere, that is actually worth something now. Whereas in the other voting methods, it really never was. All right. So the way that we do this is we look at how many choices we have, and for this particular vote we had 4 choices. So if you get a first place vote, you're going to get 4 points. If you got a second place vote, you're going to get 3 points, and a third place vote gets 2 points, and a fourth place vote gets 1 point. So the first thing you want to look at in these board account type situations, you want to look at how many choices you have, because that'll kind of tell you how to set up your points. So if you only had 3 choices, you would go 3, 2, 1. If you had 7 choices, you would go 7, 6, 5, 4, 3, 2, 1, so forth and so on. All right. So the other thing that I like to do, now that I know how the points are set up, is I like to set it up in a lattice multiplication type situation. So you'll notice that I extended the boxes here so we have some room to write. But we'll go through and start tallying up points, and you'll notice that it's really just lattice multiplication as we work our way across. All right, so Seattle got a first place finish in this particular schedule here. And remember, a first place vote is worth 4 points. And there were 51 people who gave Seattle a first place vote. So I'm going to do 51 times 4 points here. And Seattle would get 204 points for this position on the preference schedule. Now, Tacoma got a second place vote, so those are worth 3 points apiece. So we got 51 second place votes, so we would do 51 times 3, which would get us 153 points. Tacoma got a third place finish, so they would get 2 points for every one of their votes. So 51 times 2 is 102 points. And then Puyallup got 4th place in this particular schedule, so we do 51 times 1, which gets us 51 points. Right, then we'd go to the next column and do the same thing, right? So we do 25 times 4. Since Tacoma got 25 first place votes, that would be 100 points, right? Then 25 times 3 for Puyallup, which is 75 points. 25 times 2 gets us 50 points for Olympia, and then 25 times 1 gets us 25 points for Seattle. All right, same thing here with this column. So we've got 10 voters that put Puyallup first, so that'd be 10 times 4, which is 40 points. This would be 30 points. And this would be 20 points, and this would be 10 points. All right, last column here. So 14 first place votes for Olympia. So we do 14 times 4, which is 56 points. And then 14 times 3, which is 42 points. And then 14 times 2, which is 28 points, and then 14 points down here for Seattle. Okay, so we've got all the points assigned to the different positions on the preference schedule. Now we just got to go through and we got to add them up. So I'm going to find all of the boxes for Seattle, and I'm going to add up the point totals in each of those boxes. So I would do 204 plus 25 plus 10 plus 14. And then I do the same thing for each one. So I'm going to fast forward that a bit so you don't have to watch me write down. All right, so I got them all ready to add up here. So when I add up Seattle's points, we get 253. For Tacoma, we get 325. For Puyallup, we get 194. And for Olympia here, we get 228. And we see the city that got the most points from the board count is 325 for Tacoma. So Tacoma wins the board count. Okay, so Tacoma won, so those second place votes ended up being pretty valuable, as those second place votes were the primary reason why Tacoma was able to win that election. So board count gives a lot of weight to not necessarily being first place. You get a lot of weight for being in first place, but you also get a lot of sway in an election for also being the second place choice. All right, so let's take a look at another example. Make sure we got this nailed down here. All right, so in this next one, we've got our GMB election again here. So we're going to do it with a board account, same way that we did in the last example. Notice that we had some voters here that refused to rank them. They only gave their first place choice here. So these 20 and these 39 only gave their first place vote. So what we're going to do is in this one, since M and B did not vote, I'm just going to write them in. And it doesn't matter which order you write them in because they're only going to get 1 point if they were unranked. So we're going to give every unranked candidate 1 point. So these guys would automatically get 20 and 20. And then over here, same thing. So G and M were not ranked in this one. So they would get 1 point for each vote. So they're going to get 39 apiece. All right, so those are automatic. So I'm going to fill those in before I go any further. And then also remember, this one only has 3 choices. So a first place vote is only going to be worth 3 points. And then it'll go 3, 2, 1, down like that. And then I can start my lattice multiplication, working my way across and assigning points to each of these positions on the preference schedules. All right, so for instance, for G, I'm going to do 3 times 44, and when I do 3 times 44, I get 132. So I'll just write my 132 here in the box. It might get a little cramped, so just write small. And then I'm going to do that for each subsequent box. So I'll kind of fast forward through that. All right, guys, so I got all of my points assigned. So like I said, all I did was I went through and did the multiplications for each one. So this might be a good point for you to just pause the video and see if you got the same numbers that I did. If you're trying to do this problem alongside me, you might want to pause, see if you can do it yourself, and just check your numbers and make sure you didn't make any mistakes there. Or I could have made a mistake, who knows? But now what I'm going to do is I'm going to go through and I'm going to tally up the votes for each of the 3 candidates. Right? So we've got G, M, B, And so for G, I'd go find all the spaces with G in it and grab the vote total. So this would be like 132 plus 42 plus 60. That would be these three boxes here, and then 140 for this one, 22, 80, and then 39. And we would add those together and get a total. So I'm going to do the same thing for M and B, and I'll fast forward through that to spare you the pain of watching me write all those numbers. All right, so we got all of our tallies here. So you'd grab a calculator, you would put this string of addition in, and here are the numbers that I got. I got 515, 597, and 491 here. And like I said, feel free to double check my numbers. I could have easily made a mistake here, but based on what I'm getting here in my preliminary results is 597 for M is the winner, right? So M wins Borda count here. So there you go. All right, so you're probably noticing, just to kind of wrap up the Borda count thing here, you're probably noticing Borda count is so far probably the most tedious of the methods that we have learned so far, and that it does require a lot of multiplying and adding, and there's a lot of numbers, especially if you have a lot of choices and a lot of voters. It can be a very tedious process, but a lot of people like this because you get more credit than just being in that first place position, right? So if you are a second or a third place candidate, you still have a chance to win that election, all right? So just some of the benefits that go along with it. All right, guys, that's it for today's lesson. Tomorrow we'll look at some of the issues with Borda count and see if we can find out what can go wrong with a Borda count type election. Have a great day, guys.